the last 2.5 years, so we're excited about that. A minute 50. $130. One minute. How are we doing?
I don't even know Pat, bro.
What's that?
I don't know Pat.
All right. 40 seconds. $25. Morning. 10. That's it. Put your pens down and you're on your iPhones as well. I'm only kidding. Okay, so how many people, and I move around a lot, I just can't stand in one place. So how many people got 10 answers? Okay. How many people got 10? Raise your hands. How many people got 5? 3? How many people got 1? How many people got 0? Keep your hands up. You're going to like the fact that you got 0. I'm going to show you a quick video now about what this exercise, what this initiative is all about. Ian, can we show that?
My name is Will Shorts. I'm crossword editor for the New York Times. This puzzle has a special story behind it. Only one person knows all the answers, but she doesn't remember them anymore.
Alzheimer's is a devastating disease. We wanted to demonstrate its effects and show how the AFA can help. So we took a common hobby and transformed it into a way of experiencing the disease. First, we learned facts about patients' lives by interviewing their relatives.
My grandmother is Catherine. She had forgotten to feed the dog. She found a doll, named it. My dad's name is Richard. My name is Dad. Completely burned the fried chicken.
Then, we had Will Shorts create puzzles based on each patient's life and the answers they can no longer find. We worked with the biggest newspapers in the United States to have the puzzles covertly published, making enthusiasts struggle to find the simplest answers. In addition to the newspapers, a range of media drove people online, where they could learn more about how the AFA can provide support. We showed the effects of Alzheimer's through a crossword puzzle that not a single person can solve. We reached over 5 million newspaper readers, a total of 50 million adding other media. AFA saw a 159% increase in web traffic and another 62% in calls. And with unsolvable crossword puzzles, we helped many find the answers they needed.
So do you feel better that you got no answers? Much better. So we wanted to challenge people throughout the entire country, and we were approached by a healthcare public relations firm in New York City called Area 23. And they called us actually sent me an email. And we called them back, and we said, what is this all about? And we said, look, we've done extremely well in our careers, and we want to give back. But we want to come up with an initiative that challenges people, that allows people to experience frustration and an inability to perform such a simple task as filling out a crossword puzzle with some simple questions. We were honored to partner with, and does anybody do the New York Times crossword puzzles on Sundays? Okay. So Will Shorts is the editor of the crossword puzzles, and we were honored to have him to be part of this. So for 3 minutes, you experience frustration and an inability to perform a simple task. And that's what individuals living with Alzheimer's goes through every day. So you feel better that you got no answers?
Absolutely.
Right? So thank you so much for taking that. So we're delighted to be here. Approximately 2 years ago, I'm going to talk to you a little bit about AFA. We celebrated our 15th anniversary. And I wanted to do something a little different. Our model is all about care, education, and research. We were founded by a caregiver, and this is why we're here today. So I embarked on an Educating America tour. In the last 2.5 years, we've been in approximately 40 states throughout the entire country. And we're based out of New York City, but we have more than 2,900 member offices nationwide throughout the entire country, and that's our network of services. So we were founded by a caregiver. Somebody back in the 80s and 90s who was caring for his mom. Lived in New York on Long Island. His parents lived in Florida. He noticed something different about his mom and dad, especially his mother. And he wanted to put a healthcare worker in the house full time, and his mother resisted. But when his mother called him up and said, Bert, don't worry about everything. I just took Dad to the doctor and I saved you money. It only cost me $2 for the copayment. But he found out she took him to a pediatric clinic for the dad. So he knew something was wrong, and his mother kept resisting about putting a healthcare worker in the house. So he did something very drastic. He sued his parents. And when he walked into the courtroom, and you can imagine how emotional it was. He's on one side, and his mom and dad are on the other side with his brother. The judge walks into the courtroom and said, Brodsky versus Brodsky. How much money is involved? And he says, Your Honor, there's no money involved. This is all about providing care for my parents. So after his mom had passed away, in the 80s and 90s, nobody talked about this disease. The stigma was much larger than it is today. We've broken barriers. But he had no place to turn to for any guidance, counseling, or support. So he wanted to do something on a national level so that nobody would go on this journey alone. And that's how we founded AFA. And back then, initially, it was a hotline. We now call it a helpline, which is staffed by licensed social workers that are dementia-specifically trained. It was really started off as a referral service with 1 or 2 organizations throughout the entire country. Today, we stand with more than 2,900 members, other nonprofits, whether they're research facilities, nursing homes, assisted living, small or large nonprofits that provide therapeutic services. But it allows us to make a referral anywhere in the country that's geographically close. Our network on a daily basis helps about 2.3 million people that are suffering from this disease. These are some of the programs and services that we do on a daily basis in our offices throughout the country and in New York City as well. We've trained more than 19,000 people in dementia-specifically training through our training programs, which we're very happy about that. We've provided free memory screenings, confidential screenings, to more than 5 million people nationwide. We're offering memory screenings today. Here's the question. Who's afraid to take a screening? Okay, let me just ask this again. Who's afraid to take a screening? I was, when I first started with AFA 5.5 years ago, to think that an employee of the company is going to take a screening of me, and if I do poorly, I'm going to be running the company. How's she going to look at me? So we're offering screenings today right outside, and I know some individuals have taken it already. Take advantage of it. In your booklet there, in your program, you're going to find our phone numbers. Our helpline is staffed. It's 7 days a week, staffed by licensed social workers that are dementia-specifically trained. No volunteers. They're AFA employees, and we're very proud of the fact that we do that. Part of our model is care, education, and research. We fund research all over the world, from as far east as Stony Brook University on Long Island, all the way to the Hadassah Medical Center in Israel. We're very proud of the work. Most of our research is focusing on better treatment. Some of the projects are focusing on treatment, better treatment for hallucinations and agitation. We're very proud of the fact that Senator Collins is going to be here today, and we're going to talk a little bit about what she's done with the research level, because for the first time, the federal government has appropriated more than $2 billion. Our public policy division in Washington is on Capitol Hill all day long, and believe it or not, they do get things done in Washington once in a while. So we're very proud of the fact that we advocate all the time for research dollars and programs for caregivers as well. But when you look at this, and you see the cost of caring, just one individual is more than $60,000 a year, more than $250 billion a year it costs this country. This is a national epidemic that Washington, the federal government, needs to recognize. When you have more than 5 million people living with this disease, and that's expected to triple by 2060, this has to be taken more seriously than it is throughout this country. In an effort to raise the awareness of Alzheimer's disease and start the discussion and let people know that there are places to turn to for help, on November 7th, and this is our 4th year doing this, we have more than 300 landmarks throughout the entire world that light up in teal. And what does it do? People ask why. Teal is our Alzheimer's awareness color for the AFA. It starts the discussion, and people start talking about this, because we always want to break down that stigma and that barrier that's associated with this disease, because it's critically important to know you can't go on this journey alone. Once this disease walks into your front door, whether it's for somebody, it's for yourself, or you're caring for somebody, you need a team. It's impossible to do this, because if you burn out as a caregiver, you're no good to yourself nor the person you're caring for. This is where our tour has been this year alone. We're very excited that we've been all over the country, and we're really excited that we're here today, knowing that nearly 30,000 people in your state are living with this disease. It's all possible. We don't charge anybody for our conferences, and you had a great breakfast. It's all possible from our sponsors, and we're really grateful of that. Every single day, and I always say this with all due respect to our staff, because I don't want them to think that I don't think they work hard enough, but it's never enough, because the disease is so prevalent. And every day, every second, every minute, every hour, somebody else is being diagnosed with this disease. So our goal is to help more people today than we did yesterday, and we strive to do that every single day. We have some great offices that are here today, and that's part of the conference, is to bring the services to you. Project Lifesaver International is here, our great friends and partners. The George and Ann Ryan Center Institute for Neuroscience, the Elder Law Offices of Kathleen Kienitz, University of New England Center for Excellence in Aging and Health, and the Hospice of South Maine. Take advantage of their services and take advantage of them being here. Again, give yourselves a round of applause, and thank you so much for being here today. So we're going to go right to the program today. You know, I said Kathleen Kienitz will be here, and she's going to be talking about long-term care. Senator Sue Collins is going to be here. We're excited to have her. And Dr. Paula Grammas is here. I'm very excited that she's taking the time to be with us today. Dr. Grammas is the Executive Director and Thomas M. Ryan Professor of Neuroscience at the George and Ann Ryan Institute for Neuroscience in Rhode Island. She is a cognitive neurologist who holds a PhD in neuroscience with an emphasis on structural and functional brain mapping from UCLA. She is known for her pioneering research into the role that blood vessels and inflammation play in the development of the diseases, including Alzheimer's and other neurodegenerative diseases. She has published more than 140 peer-reviewed research papers and has received numerous awards for her research. We're honored to have her here. Ladies and gentlemen, please welcome Dr. Paula Grammas.
Thank you so much. Appreciate that. Thank you very much. Thank you. Okay, he made you do a crossword. I was going to pass out an actual science test, so everybody get their pen and paper. We got a couple hours, talk science. So, no, I promise I won't do that. But it's my pleasure to be here, and I very much appreciate Charles's comments. I think we share a common goal and a common vision of a world without Alzheimer's. I've been doing this for research into Alzheimer's about 30 years. I know I don't look it, I look like a puppy, but I have been around a long time, and I'm sorry to say that as of today, we still have no disease-modifying drugs for Alzheimer's. And as Charles was saying, it's an international epidemic, and we in the medical and research community really need to do what we can to educate folks, which is partly what we're doing today, about things we can do to reduce our risk but from our perspective also to dive into really what is happening in the Alzheimer brain and how we can possibly help prevent this disease, treat this disease, and help people improve their quality of life. So what I wanted to do today was really touch on a little bit of both of that, what we think are some of the risk factors and things people can do today, as well as where we are with research, because every time I give a talk anywhere, people are very interested. That's why you guys are here. This is such a terrible disease, and there isn't a lot of general knowledge about Alzheimer's and what's going on, and I think everybody wants to know. So with that, I'm going to get started, and I have two screens. I'm not sure where I'm supposed to look, so I'll just look at all of you. How's that? So again, we're going to begin with an introduction, because I want to make sure we're all kind of on the same page. We're going to talk about what dementia is, our statistics, therapeutic challenges, as well as really what is the basis of Alzheimer's disease. So let's talk a little bit about what dementia is. Sometimes people I want to make sure, as I said, we're all sort of on the same page. So dementia is really the loss of a cognitive function. You lose the ability to do something that you were able to do before with your mind. It is not synonymous with Alzheimer's disease. It's a condition that can come about from other things, but Alzheimer's disease is the most common cause of dementia, but dementia can come from other things as well. It's just the clinical presentation. And again, it's a group of symptoms that have difficulty in memory and in language, and ultimately have cognitive problems that impair your activities of daily living. But I think it's important that we don't use Alzheimer's and dementia interchangeably, because dementia is a symptom, Alzheimer's is a disease. You know, years ago people used to say, oh, well, you just get old and that's what happens, and that's what Alzheimer's is. So that's not what Alzheimer's is. Alzheimer's is an actual disease, which it's important to know, because diseases have causes and diseases can have prevention strategies and treatments. So we need to keep that in our mind. So again, what is Alzheimer's? It's the most common form of dementia, and of course, like any of these diseases, there's various stages. The milder form, the moderate, the more severe, progressively increasing inability to do the things that we normally do in our daily lives. So for any of you here who know folks that have had AD or family members, you know that this is a progressive disease and that these are the various stages. And being able to understand that and really recognize them as they begin is, I think, increasingly important. You know, again, years ago, people didn't really appreciate. When I was at the University of Oklahoma many years ago, we had Maureen Reagan come and give a talk, President Reagan's daughter, and she was saying that the family just didn't know. She would sit with her dad at one point, and he was talking about some movie that was really one of his important roles, and she asked him something about it, and he didn't seem to remember it. And she didn't understand at the time that that was a symptom, that, not remembering something that's critical to you. People are concerned, I think, oh, I left my keys somewhere, I have Alzheimer's disease. That's not Alzheimer's disease. Everybody has memory lapses where they forget things. But when you forget something that's fundamental to who you are and, an important part of your life, that's a clue that there's really a serious memory problem that's evolving. So the hallmarks of Alzheimer's disease, we're going to talk a little bit about that. But again, as Charles was mentioning, the statistics are very daunting. Again, over 6 million folks now, terrible disease for those who have it, terrible disease for the families and associated individuals related to the family. The cost to the United States and actually globally, it's a disease that if we don't do something in the next 10 years to slow this train down, the potential to even really bankrupt the healthcare system, I think, is very real. So the pressures on all of us in the medical research community, I think, are pretty intense to do something and do something meaningful. Again, 18 billion in unpaid caregiving hours, just the total cost to society and lost productivity of family members is hard to measure. More women than men are caregivers and patients, and so I think a lot of the burden falls disproportionately on women. So sort of change in death rate, I show this slide because, again, I think it's important to understand that we in the medical research community have done great strides in improving outcomes for many diseases, including stroke and heart disease particularly. diabetes, lung cancer, but Alzheimer's disease, we really haven't made an impact there. The percentage related to the death rate, these are statistics from 2000 to 2014, really shows us that we have a long way to go in intervening successfully in this disease. And again, that all comes down, as Charles was saying, to research and what we all need to do to support that. So the fundamental challenges of Alzheimer's therapeutics, the drug failures, are numerous and varied. Again, we've had many clinical trials between 2002 and 2012, and when we look at a failure rate of over 99%. So again, today we have no disease-modifying drugs. What we have are symptom-modifying drugs, which is not to minimize their importance in their utility. Patients that take the drugs that are currently available, the 5 that are FDA approved, can improve and maintain quality of life for a period of time. But ultimately, those drugs don't get at the root cause of Alzheimer's disease, which we're going to talk about in a moment. But the drugs, the root cause of Alzheimer's disease, as we'll reiterate in a bit, is that nerve cells in the brain die. The drugs that are currently out there help nerve cells to communicate with each other, because the first thing that happens is that there's a miscommunication. So those drugs promote a good environment for communication, but ultimately as the disease progresses and the nerve cells die, those drugs can't really help. So again, the imperative to develop some kind of therapeutic strategy to get at what is killing the nerve cells in the brain, I think, is really important. So why do we have all these drug therapy failures? Well, I think Alzheimer's disease is a very complicated disease. Lots of things going on in the brain. And really, when you think about it, the primary risk factor for developing Alzheimer's is age. So that says that whatever's going on here has been going on for a really long time. And it's hard as a researcher, as a scientist, to begin to understand how you could look at something that probably takes decades to manifest and understand how to intervene and get in there and do something. So it's a very, very hard problem. That doesn't mean it's unsolvable. It just means that it's difficult. And also, when we talk about Alzheimer's disease, it's not really a single disorder, but it's, I would say, a group of these dementing disorders that in the end have this common clinical presentation, the dementia, common pathology that I'll show you, but multiple ways to get there. And there's a form of Alzheimer's called early onset, which probably has a different kind of developmental process, and that strikes people that in their 50s. Most people have what we consider late onset, where the peak age for Alzheimer's is over 65, but even that, likely very complicated. And one of the research areas that's really evolving currently is this idea of looking at patients, looking at the ability to look by imaging, which is a technology that's evolving on a daily basis, to understand really what are sort of the subtypes of Alzheimer's. And again, understanding that would give us some window into how to develop therapies. So very complicated situation, but hopefully we'll make progress. So again, this is the part where you normally would have to take notes, but I'm going to give you a free pass today and just tell you a little bit about the background, because I think it's important to know. So in Alzheimer's disease, as we were talking about before, research is super important. So the research in Alzheimer's disease has really focused almost, I would say, almost exclusively or heavily in this idea of the amyloid protein. In the Alzheimer brain, there's this deposition of this particular protein, amyloid. And for 30 years, there's been a lot of interest in what we call this amyloid cascade hypothesis, trying to understand how the protein comes about, what it does, blah, 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 with the idea that, okay, we think this protein is important in Alzheimer's disease. We think it's, again, what is the key issue in Alzheimer's disease is nerve cells are dying. So the idea evolved because people looked in the brains of people that had died of Alzheimer's disease. They see a lot of amyloid, and the idea is, okay, we think amyloid's got something to do. If we could prevent its formation, perhaps that would be helpful. The other thing that we see in the Alzheimer brain are these tangles, which has this tau protein. So people started looking 30 years ago in the Alzheimer brain, again in post-mortem autopsy samples, and they saw neurofibrillary tangles, tau, they saw amyloid, and they said, okay, these things are in the brain. So if we understood how we got these things in the brain, maybe if we target some therapies to prevent that, that would help with the disease. That hasn't turned out to be the case. because a lot of work has gone into the amyloid protein and understanding it, and many of the clinical trials that are currently ongoing and have not been successful have been targeting this protein. And my idea is really, I think that we've taken a route that isn't productive. For instance, the analogy that I like to make is that if space aliens came down to Earth and they saw a fire, they would see firemen at the fire, and they would conclude that firemen start fires because the firemen are there, right? So that's what I think has happened a little bit in the science world. We look at the brains of people that have died of AD, we see these tangles and this amyloid, and we think it's got something to do. But maybe it doesn't, or maybe it's just so late in the process that targeting it isn't helpful. So this is partly, I think, why we have no disease-modifying therapies. Partly, very complicated story, but partly, I would say, a pretty narrow research focus, which I think in the last 5 years is changing, and I'll talk a little bit about how I think we're casting a wider net and why I'm more hopeful today with the idea that we're going to have something in the next couple of years that's going to help us therapeutically. Because ultimately, it's not the amyloid and it's not the tangles. Really, the basis of the reason why people have memory lapses, language issues, and ultimately this progressive disease is because the nerve cells die. That's the key issue. So that's what we have to focus on. That's what we have to understand. And I have just an actual autopsy. So just to show you that, again, there's shrinkage in the brain. There's shrinkage in the brain because nerve cells die. And the areas that are particularly affected, at least earliest, are those areas associated, again, higher cognitive function, language, memory. So if we can all accept this idea that we think that the basis of dementia and Alzheimer's disease is that nerve cells die, that anything we can do to prevent or improve nerve cell function in the brain would help us on that path to either preventing and or treating Alzheimer's disease. Which brings us to the issue of risk factors, because again, risk factors are important because we want to understand, are there things we can do in our daily lives that might lower our risk? Risk factors are understanding how they are involved is also important because it gives scientists and researchers kind of a window into the disease. Because if we understood what makes you more likely to get Alzheimer's or less likely, that should tell us something about how the disease is developing and give us ideas as to how to get after it therapeutically. So risk factors fall generally into two categories: those that we can change, and which are what we call modifiable, and those that we cannot, both positive and negative, and we're going to talk a little bit about both of those. So risk factors for late onset AD. Number one, age. Okay, none of us are going to really want to work with that because the surefire way not to get Alzheimer's disease is to die young. Anybody want to buy into that? Probably not. So we have to take that one right off the table. Okay, genes. Again, most of us probably can't do anything in the year 2019 about our genes. Maybe in 100 years we'll be able to do something about that. Right now, your genes are your genes. And again, I think we talk about the genetics of Alzheimer's disease. As I mentioned before, there's a form of Alzheimer's that's considered early onset. There's a really important genetic component, but most people that have what we call late onset AD, it's not a genetic disease in the same way that Huntington's is, or cystic fibrosis. For cystic fibrosis or Huntington's, if you have that gene, you get the disease. It's really one-to-one. You have the gene, you get the disease. Alzheimer's disease, late onset, is not that way. Your genetics are important because they are part of your overall makeup. My risk is different than your risk, is different than your risk because of our genes, right? And people always ask, well, if I have a family member, yes, there is some enhanced risk if there is Alzheimer's in the family, but it's not huge. And again, it's a multi-genetic component. There are multiple genes that may contribute to your risk for Alzheimer's disease. It's not one-to-one. The ApoE4 gene, many of you may have heard of. There's been a lot of press over the years about ApoE4, that if you have this gene, that you have an enhanced risk for AD, which it's true, you do have an enhanced risk, but again, the risk, the amount of risk is not that great. And again, it's not if you have ApoE4, you get the disease. That's absolutely not true. So the genetics are very complicated. Family history contributes. We know know that if you have a history of traumatic brain injury, that you have a higher risk for developing Alzheimer's disease. We're going to talk about some of these others in a minute here, hypertension, diabetes, because they would fall into the category of what I would consider modifiable risk factors. Protective factors. Again, we're learning more and more that if you have many years of education, that appears to be somewhat protective. And again, why might that be? As we talked about before, nerve cells die, but nerve cells communicate with each other. We think that if you have many years of education, if your brain is highly engaged, such as with the crosswords that you guys were doing before, that your nerve cells are really well connected. The more connections you can have in your brain, the better. So that in theory, if you develop this terrible disease and you little by little start to lose that, having more connections to begin with is helpful because you're starting at a better place. Heart health, we're going to talk a lot about heart health in a moment, and social connections and physical activity. All the good things fall into the category of what we call modifiable risk factors. And that whole idea, I think, is really important because years ago, again, when in this field, you would give a talk and people would say, is there anything I could do to lower my risk for Alzheimer's? And most people would say, no, not really. But I think today we know that there are things you can do to lower your risk. Now, does that guarantee that you won't get Alzheimer's? Can I sign a piece of paper that says if you do everything I say, which no one ever does everything I say, not my daughter, not my dog, no, none of that works. But even if you do everything right that we're going to talk about in terms of the modifiable risk factors, you still could get Alzheimer's because there's still that black box that we don't know everything about the disease. But anytime you can tell someone you can lower your risk, lowering your risk is a worthwhile goal. I think that's something, anytime you can do something proactively to better yourself and better your chances for not getting this terrible disease, I think that's worthwhile. And I think, again, we in the medical research community haven't done as good a job about educating people, and that's what's, I think, really nice about this AFA tour, taking education as much as possible to the public so people learn what are the things that we can do today that might be useful in minimizing our risk for AD. So yes, we have modifiable risk factors. And yes, so the Lancet Commission recently published, which was a really important study, and they claim, and I think they have a lot of basis for that maybe as much as 30 to 35% of all these dementia syndromes, of which AD is the most common, could be prevented by just lifestyle alteration. And I think that's really a powerful statement. You know, years ago when I went to a conference and I saw some data that was presented about the importance of physical activity, which we'll talk about in a moment, as for prevention for AD, the data was so impressive that I thought if this was a drug, it probably would have been the front page of the New York Times. But somehow, because it wasn't, it hasn't received, I think, the attention that it needs. But we're going to talk about that in greater depth in a moment. So lifestyle matters. Again, we think a good percentage of dementias, including AD, could be altered by lifestyle modifications. And you know, what are we talking about there? We're talking about cardiovascular risk factors. We know that lowering cholesterol, increased physical activity, good diet is important for heart disease. Do we know that that's important for Alzheimer's disease? I mean, is that a message that generally people have? I don't think so. I think we really need to get that out. This idea of what's good for the heart is good for the brain. That's a message that I think is really important because we've done great strides in lowering risk for myocardial infarction, heart attack, and stroke. But we haven't done so good with Alzheimer's. And I think putting that out there, hypertension, lots of really solid data that says if you have hypertension in midlife, in your 40s, you have an enhanced risk for developing Alzheimer's later in life. If you have high cholesterol in midlife, again, 40s, you have a higher risk for developing Alzheimer's in late life. So this really brings the question of, again, what are the things we should be doing? Alzheimer's disease doesn't come to you one day when you're 65 years old. This is a decades-long process that's ongoing in the brain. People always ask, well, is there more Alzheimer's now than there used to be in the 20s and 30s and 40s and 50s? And yes, and part of that is because we're living longer lives. I mean, in the 50s, the primary causes of death, a lot of them were infectious disease and other things. So if you look globally, for instance, the continent of Africa, where the life expectancy is lower, there's a proportionally lower incidence right now. But I'm going to predict in 5 to 10 years, as their life expectancy increases, in all the developed countries of the world that have a similar life expectancy to the US, Japan, Europe, the incidence of Alzheimer's is the same. And again, I think it relates to the fact this is a disease that takes decades to manifest. It doesn't mean that what goes on in your 30s and 40s doesn't have implications for later in life, because it does. So this is where I think we need to really get the education message out. So we talk a little bit about diet. So this is the part that everybody doesn't like. Oh, you mean I have to be on a diet? No, you don't actually have to be on a diet. Again, it's all sort of common sense stuff that we've learned in the heart world. We've learned that, again, what are we talking about? We're not talking about, there's all kinds of, lots of times I get questions about the various and assorted diets and fad diets, and should I do paleo, should I do this, should I do keto? The idea is very common sense. You should do the things that are good for your heart, and everybody knows what those are. A little bit less meat, a little bit more fruits and vegetables, a little bit less processed stuff, a little less sugar. All these things we know are important, what we call the Mediterranean diet. And I get to brag on the Mediterranean diet because I'm Greek, so I feel like we brought this to the world. A lot of it hasn't worked out so good. So clearly, I mean, it's all stuff that we know. It's not, it's not brain surgery. It's just a good approach to food, and understanding that food is medicine. They used to say food is important. That's part of the whole modifiable lifestyle choices that we make, what we eat. So again, getting that message out. I used to have this slide. I think I took it out because I think they made me take it out. But talking about red wine, a big controversy. People say that a little red wine is good. So I think there's a lot of data that suggests that yes, a little red wine is good. Sometimes we say more is better, but I have actually a little coaster in my office, and it says, doctors recommend a glass of wine a day. And then it says underneath, thankfully I have 6 doctors. So there you go. But so I'm not advising you to go out and drink a bottle of wine, but I do think that, again, part of the balanced diet could include some red wine as well. So that's all we need to say about that. And again, lifestyle related to exercise, lots really solid data, I think, in both animal models as well as in human population studies. Really important for lots of things. You think about what exercise does in terms of so many different physiological processes in the body. And as I've mentioned earlier, when we've seen data at these conferences, it's really astounding. So again, lots of recommendations over the years about physical activity, what people can and can't do. I think anything that you can do, you should do. Obviously, people have different capabilities at different ages in their lives. It doesn't mean that when you get to it, as you get older, that you should do nothing. You should always try and do something. Any kind of exercise is beneficial, and I would certainly highly encourage folks to get the word out that maintaining physical fitness over life is really important as, again, a preventative strategy for Alzheimer's disease. Again, strength of the evidence. This is an evolving slide. I think probably needs to get updated a bit. But again, all the things that we talk about, traumatic brain injury, midlife obesity, midlife hypertension, all these things we know are really very bad and really increase your risk for developing Alzheimer's disease. Diabetes, that's another thing that, again, when you think about where we are as a country, the obesity epidemic, obesity increases your risk for diabetes. We know that. Diabetes, we now know, is an important risk factor for developing Alzheimer's disease. So when you think about all those very scary statistics that I showed you earlier and that Charles mentioned about the incidence of Alzheimer's and where we're going, let's start to factor in what's going to happen when people that have diabetes have a higher risk for developing AD, and that the incidence of obesity is higher. I mean, the numbers just get bigger and bigger and scarier. So I think, again, the things that we could do potentially to modify lifestyle-wise, this idea of obesity and what we consider the metabolic syndrome, which is sort of the culmination of all these cardiovascular risk factors as well as diabetes. We're also learning a little bit more. Right now it's showing you this sort of unclear evidence, but there's a lot of evolving data that looks at sleep and stress, and again, how these things factor into, we used to think that, what does the brain do when you're sleeping? What is sleep? Sleep must do something pretty important because all species sleep, right? So there's something, we haven't quite figured that out, but there's a lot of recent research into the idea that having good quality sleep is important for your brain, because part of what goes on during sleep is almost like a house cleaning in your brain, and your brain needs time to do all these things, and you only get the house cleaning part when you have good sleep. So again, something we didn't think about maybe 5-10 years ago, something we're thinking about now. I think that's another message that we probably need to get in there. The idea of social engagement, I think that's another, people have talked about that in the past. I don't want to say it sort of dismissively, but it's hard sometimes from the scientific perspective to quantify all these things. And generally, we scientists, we're a little snobby. When we can't quantify something, we tend to go, oh, well, whatever, But I think, again, more and more good epidemiological evidence that says that sometimes as we get older, we tend to socially isolate. That's not a good thing. Sitting in front of your TV by yourself is not a good thing. Again, when you think about what are you trying to do, you're trying to maintain your nerve cell, your neurons in the brain. You want to maintain their health. And what maintains their health is this interaction, learning new things, doing new things, engaging with other people, reacting to situations. Working with a computer is way better than watching TV because it's not unidirectional. You're not just processing what's out there. You're interacting. And anytime you can do that, you're stimulating your nerve cells, and that's a good thing. So we want to make sure that, again, that's part of the message. What can we do to prevent Alzheimer's and the dementia syndromes? We can eat better. We can be more engaged. So again, the take-home message from this part is really what's good for the heart is good for the brain. That's the easy way to remember it. And it's really just not that complicated, but it's a message I think that we haven't gotten out and we need to. So what you can do today, protect heart health, eat a good diet, engage in the world, get enough sleep, manage stress. Oh, that's a hot one. Okay, well, for those of you with a stressful job, probably been hard to do that, but we do what we can. Move more, sit less. Yes, people joke that sitting is the new smoking. Well, okay, I wouldn't quite go that far. But I would say that, again, part of thinking about physical activity is helpful. And that, yes, join a registry, volunteer, all worthwhile activities. So where are we in terms of, those are the things that you guys can do. Okay, now I need to talk a little bit about what we guys can and should be doing in the research community, and where are we and where do we think we could go for the future. So some good news and some bad news. So it's always a little bit of both. So the good news is that there was this trial that was reported last year, the SPRINT trial, which really had very conclusive evidence, I think, about hypertension. And again, the importance of, if we can keep blood pressure under control, that has a very direct positive effect on brain function. So that, I think, is very solid and very key. And that's important that we go forward and continue to look at ways for people to manage their blood pressure. Lots of disappointing news on various and assorted trials. Biogen had a very high-profile failure with their drug, and many of you may have heard that a lot of the big pharma has pulled out of their neuroscience research, and because they've lost billions. But in the end, we have to go forward. We still have to come up with some therapy. So part of what we need to do now, as I mentioned, is to have broader targets. We have to cast a wider net. We've done a lot of work looking at amyloid and a lot of work looking at the neurofibrillary tangles. Now we need to look a little bit more broadly at what are other pathways that we could target for drug development that could be helpful for Alzheimer's disease. So this is where we're going to talk a little bit about what's near and dear to my heart and what we've been doing for almost 30 years, is this idea of blood vessels. Why should someone be interested in the brain blood vessels, and how might that give us a window? Well, first of all, as we've talked about, what's good for the heart is good for the brain. So that should already give us some idea that maybe it was a worthwhile idea to look at brain blood vessels, because again, heart health is directly related to blood vessel health. Plus, I love this slide because this is a cast of your brain to show the blood supply to the brain. So I think the take home is the brain is a very vascularized organ. Even though it's only 2% of the body weight, it gets 20% of the cardiac output, and there's over 400 miles of blood vessels in your brain. So think about that. All right, so there's a reason to look at blood vessels. I mean, I think it's interesting to me. We've been doing this for a long time, but as a field, there's been resistance, I think, to look outside the box of amyloid and tau, to look at these other ideas. But now, as we think again about risk factors, what do the risk factors tell us? They give us a window into what's going on. And we know cardiovascular risk factors are important. So it seems to me it's not the great leap to understand how vascular blood vessel function could be altered in Alzheimer's disease. So again, this idea that we've only looked at the nerve cells, we've only looked at amyloid and tau, it hasn't been fruitful. And again, epidemiologically, there's a lot of data that suggests that the vascular risk factors are also important for Alzheimer's disease, and that what we know about heart disease and Alzheimer's disease share some mechanisms, some of which I'm not going to directly get into, but this idea of inflammation, oxidative stress, these are all mechanisms that we think have been well documented in heart disease, and also, I think, quite a bit of information now are important also in Alzheimer's disease. So if you have cardiovascular disease, Alzheimer's disease, similar risk factors, similar mechanisms, that gives you some idea that maybe there are some connections worth exploring. So, metabolic activity of endothelial cells. Okay, normally I could spend like 5 hours on this, but to just give you the take-home message. So endothelial cells are the cells that line all your blood vessels throughout your whole body. In the brain, they are highly specialized and they do miraculous things. They're very active. They're really important for maintaining how the brain works. Because generally, if you think about it, your brain, in order for it to work perfectly, the environment has to be just so. In your blood, during the day, you sit, you get up, you stand, you lay down, you eat, you drink, you do all different things. So in your blood, what's in your blood, goes up and down. Now, if everything that's in your blood got into your brain and went up and down, your brain wouldn't be able to function. So the brain has to have a very controlled environment, and it's really the job of the endothelial cells in the blood vessels of the brain to maintain that nice controlled environment. So we said years ago, how do they do that? Well, they do that by all the properties that they have and the things that they make. So we said, well, maybe in Alzheimer's disease, instead of creating this nice environment for the nerve cells, again, remember, what's the central issue in Alzheimer's disease? Nerve cells die. Well, they could die for a variety of reasons, but one reason might be that instead of sitting in an environment that's good for them, they're sitting in an environment that's bad for them. And how does that come about? Again, it's the job of the brain endothelial cell to create that environment. So from our perspective, it seemed reasonable to understand how these cells might not work in Alzheimer's disease. So many years ago, when I was really just a puppy, we developed this technique for isolating blood vessels from the brain, originally in experimental animals, and then eventually adapted it to human postmortem autopsy material to be able to take blood vessels out of the brain and look biochemically, how do they work? And really to understand biochemically in Alzheimer's disease how they don't work, with the idea that if we understood that, and we understood how they are dysfunctional and how that dysfunction might contribute to killing nerve cells, again, this might open some possible targets for therapies. So we spend decades, I might say, showing that these proteins, and again, there won't be a test this time, but if you want to come take a test to the University of Rhode Island, I'm happy to oblige you. But we spent a lot of years looking at, again, what is coming out of these blood vessels and what might that mean for nerve cell function. Because again, ultimately, that's what we're trying to get at, how nerve cells work in the brain and why they die. And we showed originally in this paper in 1999 to just show you that if we took these isolated vessels and we put them in a dish with nerve cells that we grew, that vessels from the Alzheimer brain, which are shown in red, cause cell death, which is the y-axis going up and down. And that if you took vessels from younger, people that were age-matched for AD, the yellow, you could see there's much less activity, much less killing of nerve cells. And then if you took vessels from the young, which is the white bar in the corner, you could see there's essentially no nerve-killing activity. So what this said to us was that blood vessels coming out of the Alzheimer brain are secreting something or things, maybe one thing, maybe a bunch of things. When we first published this, I thought there was going to be one protein that came out of these vessels that killed nerve cells. I was going to go to Stockholm, get my Nobel Prize, and we were going to be done. Cure Alzheimer's, done. Okay, check that box. Well, it became clear to us after this publication in 1999 that there wasn't one thing that's coming out, that there are dozens of proteins coming out. How they work, how they might contribute to this terrible process, we're still just really beginning to understand how that might work. But the key factor is blood vessels in the Alzheimer brain are altered, and this alteration results in things coming out of there that nerve cells find noxious and toxic. So we developed this hypothesis of how we think blood vessels might drive this process. So, okay, any Greek people here? Okay, I'm the only Greek. All right. So, so there's this process called, I ask because there's this process called angiogenesis. Angio comes from blood vessels, meaning formation of new blood vessels. Angiogenesis occurs in the body under very regulated conditions. During the menstrual cycle, when you lose the uterine lining and it regrows, you make new blood vessels. Sometimes when there's an injury, you can make new blood vessels. So this is a normal physiologic process, this angiogenesis, the formation of new blood vessels. So if you look at the top panel, that's what we consider this normal blood vessel life cycle, formation of new blood vessels. There's a signal to an existing blood vessel that says, hey, you need to turn on because we need new blood vessels formed. And these existing vessels become what we call activated. And they make a bunch of things. They make essentially all those proteins I showed you on 3 slides ago that I told you we spent decades trying to figure that out. So all these things are coming out of these activated blood vessels. So under normal circumstances, in response to a normal signal, you'd make all these things, and then several things would happen. A bunch of steps occur, and you have a new blood vessel. Ta-da! So that's the process of angiogenesis. Signal, things come out of the blood vessel, you get a new blood vessel, you're done. So as most things in biology work, when you have the end product, it signals back to say, we're here now, or the new blood, everything can turn down. So you have what we call feedback regulation. Everything is very tightly controlled, and that's what normally happens. What we think happens in Alzheimer's disease is there's a perturbation of this whole process, that there's a signal to the cells that says you have to turn on. And we don't know what that signal is. That might relate to high cholesterol. That might relate to something called high homocysteine, which is, again, is an amino acid in your blood that is elevated if you have heart disease and other issues. So there's a couple different ways you could tell the blood vessel that it needs to turn on. So we think in Alzheimer's disease, something tells it to turn on. And then we know for a fact that they make all those proteins because we've documented that. So then, again, for reasons that we don't understand, the subsequent steps don't happen because we know in the end there aren't any new blood vessels. In fact, if you look in the Alzheimer brain in the autopsy at the end of life, you see less blood vessels than you would see in a normal, a non-Alzheimer brain. So how do we reconcile this idea that you have this process where you would normally make these vessels, but you don't make them? So what we said is, okay, we know there's no end. So because there's no end process, the whole thing doesn't turn off. So what we think happens is that there's a signal to the blood vessels, they make all this stuff, and they just keep making it. And if what they're making is not good for nerve cells, this becomes a possible way in Alzheimer's disease that blood vessels contribute to nerve cell killing, right? Because if they're churning out all this stuff that eventually could hurt and kill nerve cells, then we need to come up with ways to target that process. So that's essentially what we're saying this hypothesis tells us, that we need to target the blood vessels' production of all these noxious factors. So again, I think I could skip that. I've more or less said the same thing. So the issue is, what are the targets? And again, this is the part where, well, the biochemists, those of you who aren't biochemists, there's a couple of different targets. And we're going to talk really about one of these proteins, thrombin, which is shown in the bottom screen. But again, we've tried to understand what are the proteins that regulate this process. And we have a lot of data, which I'm not going to, again, since I don't have 3 or 4 hours, I'm not going to go into it. But we have a lot of reasons to suspect thrombin is a key player in this whole scheme. So thrombin is many of you may be familiar with the protein thrombin. Thrombin is part of the normal coagulation cascade, how your blood clots. If you cut yourself and you injure yourself and you have to form a clot, thrombin is key for that. But thrombin also does a lot of other things. And in the brain, it's particularly neurotoxic, meaning that it has direct toxic killing effects on nerve cells. It does this through a variety of different mechanisms, as I've mentioned in this slide. We know that this protein is elevated in the Alzheimer's blood vessels. We've shown that, and again, this is just a pretty picture from a paper a number of years ago showing that in the Alzheimer brain, the green is thrombin, and you can see that we have a lot of it in the Alzheimer vessel and very little to no actually in the control, which would be an age-matched person that does not have AD. So we're very interested in thrombin. We have a lot of data that says it's not good to have a lot of thrombin in the brain. It does a lot of things that are noxious. It affects this activation of the blood vessels that we've talked about, and it's also directly neurotoxic, meaning that it kills nerve cells. So this idea is, what if maybe we should try and do something about thrombin. Maybe thrombin could be a target for an AD therapeutic. All right, well, how would we do that? Well, you could do it a couple different ways. One of the ways that we're interested in doing it is using dabigatran, which is a direct thrombin inhibitor that has been used, it's been FDA approved since 2010. It's used to treat non-valvular afibrillation, which is another medical condition that's associated, again, with abnormal clotting. But we've said thrombin does a lot of things, but we think in this instance, it's really maybe one of the key drivers of this process in the brain blood vessel that, again, we think contributes to Alzheimer's disease. So maybe if we use this inhibitor of thrombin, that could potentially be a way to treat AD. So we've begun by looking at whether or not we could, what does dabigatran do in some animal models of Alzheimer's disease? And I should just take a minute to talk a little bit about animal models of Alzheimer's disease. First of all, in biomedical research, the use of research animals is really important for understanding how diseases come to be and for testing therapeutics. The problem in Alzheimer's disease, as I mentioned though, what's the number one risk factor? Age, all right. So how do you model a disease that takes decades to manifest in a rodent that lives to be 2? So there's already sort of a basic disconnect there. Having said that, though, there are a variety of genetically modified rodents that we and other laboratories around the world use. Because I think you can ask some very specific questions about mechanisms and drugs. It's not to say that if you cure Alzheimer's in mice, you've cured them in humans. I think we've done that like 20 times already. We've cured AD in mice. We haven't cured AD at all in humans. But I think if you ask the right questions, if you ask focused questions, you can get useful answers from experimental animals. And that's about the best you can say. So we've been using some different animal models. And we've looked at, and this slide just shows you one thing, one of the things that we've looked at has been this idea that blood vessels, we've shown in the blood vessels, if you look at the bars, the blood vessels in AD make a lot of what we call reactive oxygen species, which are free radicals that are noxious. We know that this, what we call ROS, very bad for nerve cells, very bad for all cells, generally speaking. These are cell-killing molecules. So in the AD brain, in the AD vessels, there's an overproduction of these terrible species. And we've been able to show that in these animals, if we treat them with dabigatran and we look at in their brains, that there's a big decrease in their ability to release these mediators. So we also have another drug that's related to this that looks at the vascular, again, this idea of let's target this activation because the activation is what's driving all these things. And one of the things that we've shown is that in animals where we target vascular activation like we would with dabigatran, one of the nice things that we can do in experimental animals for Alzheimer's disease is we can assess their cognitive function, meaning rodents are very good at learning memory tasks when there's food involved. You teach them to find the chocolate or to find the cereal, and you teach them so they learn, and then in a normal rodent, if you test it at a later time, they remember how to get to the food. In the Alzheimer's models, you train them, but if you test them at a later time, they don't remember how to get to the food again. So it's a way to look at memory, and we've been able to show that using dabigatran and other related drugs, we could improve memory in these animals, as well as these biochemical parameters of what we think goes on in the AD brain. So we're super excited about this idea that we could look at dabigatran. The dabigatran might be something that's really never been looked at before for Alzheimer's disease and could be a window into some novel therapies, which again brings us back to this model of, okay, blood vessels. A lot of things impact blood vessel function. All the cardiovascular risk factors impact blood vessel function that we talked about. Thrombin, one of the key mediators that's released from the blood vessel. Thrombin then goes on by itself or interacting with other mediators to drive this toxic process that ends up in nerve cell death. And again, everything is geared to understanding what's killing nerve cells. So if you could intervene it here, if you could target thrombin and prevent that noxious process from going forward, you would potentially have a therapy. So I think I'm going to skip this because we have a trial that we're trying to get off the ground, but some delays. But the idea is eventually to use dabigatran, to use this repurposed drug to run a clinical trial. And I think the future of drug therapy, this idea of using repurposed drugs is very powerful. Because to go from thinking, if today I have a great idea, because I have a great idea at least once a day. So today I have a great idea on how to design a new drug. From great idea to patient bedside, you know, that's about 10 years, because you have to go through all the pre-testing, the toxicity, all the animal work. It takes a really long time. And even under expedited review, which has started the last few years, it's still minimally, 8 years from brand new drug. But if we start to think about repurposing drugs that we are very well aware of their safety profile, how they're tolerated in different patient populations, but maybe never tested in these patients with that target in mind, cognitive function, I think it's a whole new world. That's why I said I think going forward now, this idea that we're at a new place in the AD research world, we're thinking about other types of targets. There are so many drugs out there that we could potentially look off the shelf that really we have lots of data on already. We just need to think creatively. Like I think our focus on dabigatran is very well funded and not well funded, I should say, well founded. Other types of studies that are going to look at related mechanisms using repurposed drugs, I think there's a lot of reason to be hopeful there. And I also think it's important that we think about therapy in the future as a multi-pronged. There's never just going to be one magic bullet. I think we're going to go like where we are in cancer therapy, where we have a cocktail of drugs, and we have a cocktail approach, some of which is lifestyle modification, some of which are drugs like dabigatran. People ask me about things like statins. That's an evolving story about statins because we know that statins have were originally developed for cholesterol, as cholesterol-lowering drugs, but they also have direct blood vessel functions, so there's a lot of interest potentially in statins as well, but we don't quite know where that's going to play out. But my point is that looking at all these different drugs from a different perspective of what the target could be, if we can stop focusing on amyloid and tau and think more broadly about other targets to improve and maintain nerve cell function, that's what we're after in the brain, and that's what's going to give us, I think, some therapies for the future. So with that, I think we want to be hopeful because we know so much more now than we ever did, and I want to just give a shout out to everybody. As I said, I've been doing this 30 years, so science is very much a team sport, And lots of folks in my lab over the years have contributed and continue to contribute important stuff to our work. So I want to take a moment to acknowledge their contributions and to thank you all for your time and attention. Thank you.
Does anybody have any questions for Dr. Kramis? But before you do that, Doctor, I want to thank you. You emphasized what you put in your body we know affects our body, but so many people forget that what you put in your body also affects your brain.
Absolutely.
And it's so critically important, the aspects you talked about, the diet, sleep, drinking, smoking, everything, exercise, socialization. It's all too often we forget about that. One of the aspects of one of our new initiatives is what we're trying to do is educate clinicians that
absolutely.
When you go to your office, and hopefully everybody gets an annual physical, it's usually about your body, but they forget, let's get a checkup from the neck up.
Right.
And it's so critically important. And I'll tell you an example that when I was at my primary care physician last year, there was an elderly woman with her daughter. When her doctor came out, he asked the daughter how she's doing. And I said to him, why didn't you ask her? He goes, well, it's just habit. I've been doing this for 35 years. And I said, well, that's the problem here, is that all too often we forget that you need to check up from the neck up as well. So I thank you for highlighting that. You have a question, sir?
Yes, I do. Are you familiar with Dr. Dale Bredesen and some of the work that he has done?
A little bit, yeah.
Do you have any comments as to what he is doing and what he has published?
Well, that's the TNF story? Is that... Is that the tumor necrosis factor person? I'm trying to remember because there's two people with similar names.
He's the one that did the thing on alternative type of medicine and some of the things to stop progression of Alzheimer's, not to go backwards, but to cut it off by using...
Okay, so I guess I'm sorry, I was thinking of somebody else. I'm not as familiar with his work, but there's been a lot of interest in alternative therapies or alternative approaches. As I said, I think the data on risk factor management and everything that goes into that is very solid. There's also a lot of interest in other types of approaches, antioxidants, things like ginkgo biloba, vitamin E, vitamin C. Again, we still don't know where that's all going to come out. There aren't, I would say, good clinical trial data to support a lot of that. That doesn't mean that it's not potentially helpful or important. My philosophy on some of the alternative approaches is if there is nothing specifically noxious in these supplements, I think there's no reason to not try. But again, understanding sort of where we think they are in the big picture, I think we still need more information, really. So thank you. Yes, ma'am.
Most of these studies are for late onset Alzheimer's disease.
Right.
Is there funding or a lot of studies going on for the early onset?
Sure. So the question is about early onset Alzheimer's and funding and research. First of all, there's a lot of research going on in all types of AD. We have particularly focused on the late onset because that's the vast majority of patients that have AD fall into that category. But there is actually, there's a nationwide network. There's something called the DIAN study, which is actually based up in Harvard, that collects data and is involved very much in understanding the development of the early onset AD. I don't know, many of you might have seen a couple of months ago on 60 Minutes, they had the story on the Colombian cohort, which is, again, the families that have the early onset gene. And there's actually a big study going on in the Columbia group trying to understand how that comes about and if there are any therapeutic milestones that one could target in that particular group, which I think will actually end up being different probably than the late onset, but still valuable. But there is work in both. And the question about funding, actually, Charles and I were talking about that earlier. There's just never enough. Finally, the Congress, I think it's because they're all getting old, but God bless, whatever the last few years, they have actually woken up to the idea that for every dollar we invest in research, we save 10 down the road, because caregiving, loss of productivity, aside from the terrible emotional toll, We need to do something. And research, I'm sorry to say, is an expensive business. It can't be done on a shoestring. And the National Institutes of Health, NIH, is the major funder. I mean, God bless AFA, God bless some of these other private organizations that do what they can, but the NIH needs to carry the ball here. They have the resources, and they can put the resources in if they have the will. So little by little, I think that the last 2 years the scenario has improved, but feel free to, we have Senator Collins here, so let's all write our senators here and say we need more money for AD, because the tsunami, we baby boomers, we're not going to go quietly. So as we hit that peak age, it's pretty scary. So thank you for your question. Anybody else?
We have time for one more question. Sir?
I just noticed on an earlier slide, heart disease went down, diabetes went down, but AD was up.
Right.
And if they're contributory to, the increase in AD, why didn't AD go down during that period?
Yeah, that's a good
other
question.
Things
That's a
that
good question.
contribute to AD
Right.
went down.
Well, that's a good question. So, I think eventually minimizing those risk factors, if we can, as a population, I think that it will positively impact the trajectory. But the percent change in death rate is what that slide showed. The death rate percent change is still increasing for AD. But I do agree. I think we think about if we could eliminate all heart disease. But as I mentioned earlier, again, we think that's a really critical piece, but it's not the whole story, because there's still the black box, right? There's still other things going on that even if we did, knocked it out of the park for heart disease, which we're trying, it's still not everything. So that's where we're at.
Doctor, last question over here on your right-hand side.
Would you make a brief commentation on the medication Aricept?
So Aricept, yes. So the question I mentioned earlier was that there is no currently disease-modifying drug. Aricept is one of the FDA approved for the treatment of AD. Aricept does well. I think it's helpful for patients early in the disease. As I mentioned, Aricept is an acetylcholinesterase inhibitor, meaning that the molecules by which nerve cells communicate with each other, acetylcholine is a major communication molecule. In the beginning of Alzheimer's, acetylcholine goes down. So Aricept artificially elevates the levels of acetylcholine, which is great, and it helps neurons talk to each other. But as the disease progresses, the nerve cells die. So it really doesn't matter how much communication stuff you have and how much acetylcholine you have in the brain. Ultimately, the cells die. So later in the disease, Aricept is largely not effective. But early in the disease, it is. So, okay.
Is there any way of regenerating brain cells that die, or once they get that's it?
Yeah, the question is about regeneration. Boy, that's a hot topic. So, we used to tell everybody that once they're dead, they're dead. But now we might be rethinking that. So we're pondering on the scientists are pondering on that. It's not an easy fix, but it might be something down the road. So we're thinking on that. Okay.
Ladies and gentlemen, please join with me. Thank God. Thank you so much. Absolutely terrific. So you thought the puzzle was easy? Are you ready for the quiz? We're delighted to talk about a lot of what she spoke about. If anybody wants the PowerPoint, just let me know. But a lot of what she spoke about is also on our website, which is alzfdn.org. And if you're still afraid to take the memory screening test, you can go on our website and you can take it at home confidentially. The memory screening test is now available online, and that just started last week. And in the first week that we've made it available online, more than 5,000 people have taken the screening test online, which we're very pleased about. Delighted to that mostly everybody knows here. Senator Collins has served the state of Maine in the U.S. Senate since 1997 and currently chairs the Senate Special Committee on Aging. She's the founder and co-chair of the Congressional Task Force on Alzheimer's disease and has played a significant leadership role in the federal policy changes to help individuals living with Alzheimer's disease and their caregivers. Last Congress, Senator Collins authored the BOLD Act, which is a law designed to close gaps in our healthcare system and deliver more than $100 million in new resources for prevention, treatment, and care of Alzheimer's disease. As a member of the Senate Appropriations Committee, she has been the leader of a bipartisan effort to increase federal funding for Alzheimer's disease. And Dr. Graham has talked about it, and we're so delighted. I am so delighted to tell you that for the first time, the federal government has appropriated more than $2 billion for Alzheimer's research. Let's give Senator Collins an applause. She's also hardships faced by millions of families like her own who have cared for loved ones with Alzheimer's disease. When I thanked her a few minutes ago for being here and taking time out of her schedule, she said, "Of course, don't worry, this is near and dear to my heart." Ladies and gentlemen, I'm honored to have her here, Senator Collins.
Thank you. Thank you so much. It is such a pleasure to welcome the Foundation's Educating America's tour to the great state of Maine. The fact that the previous on this tour included the other Portland, the one in Oregon, demonstrates the nationwide reach of your work and also the national imperative to provide support, services, and education to individuals, families, and caregivers affected by Alzheimer's disease and related dementias as we, at the same time, pursue research. So I loved hearing the last 25 minutes of the doctor's presentation. And like you, I wanted to ask her a million questions. And I'm going to talk about some of the research later in my speech. First, I should say that like many of you here today, I have a very personal connection to this devastating disease. It claimed the life of my father, my grandfather, and two of my three uncles. In fact, in my home, it's known as the family disease. And I remember how difficult it was when I realized that my father, whom I'd always been so close to, could no longer remember my name. He knew that we were connected. He was always warm to the very end, but it was obvious he no longer knew my name. To the end, he remembered one of my brother's names and my mother's name. But I know just how difficult and devastating this disease is from my firsthand experience. But rather than to succumb to despair, we're joining together, as Chuck often says, to keep moving forward. We know that 5.5 million Americans are living with AD, including 27,000 here in Maine. And that number will only soar as our population grows older and lives longer. In addition to the human toll, Alzheimer's costs our nation an astonishing $277 billion a year, including $186 billion in costs to the Medicare and Medicaid programs. If we continue along that trajectory, Alzheimer's is projected to claim the minds of nearly 14 million seniors and surpass $1 trillion in costs by the year 2050. It's already our nation's most costly disease. So when I talk to my colleagues in Congress, and more of them have with a loved one or a neighbor or friend with this disease, but if they haven't had that, I appeal to them to support us on research by quoting the devastating economic statistics, and that has helped us build the coalition. As was mentioned, I chair the Senate Aging Committee, and I am proud to say that I was the founder of the Senate Alzheimer's Task Force. And that task force has always been bipartisan. This is not a Democratic disease, a Republican disease, an independent disease. Politics should have nothing to do with our fight to get more funding for Alzheimer's research. And indeed, one of my earliest chairs was Hillary Clinton. My current chairs on the Democratic side, my co-chairs are Ed Markey from Massachusetts and Mark Warner from Virginia. And that's the way this should be. It should always be a bipartisan effort. I am so committed to advancing biomedical research and tapping into a new public health approach that together I hope will rewrite the future of AD. First and foremost, however, we must address the present, especially when it comes to supporting the families who play such a vital role in caring for their loved ones with disabilities or illness, including Alzheimer's and other dementias. Across the United States, more than 40 million Americans provide care for their parents, spouses, and children with disabilities or illnesses. And here in our state, 178,000 Mainers care for their loved ones and help them live in their own homes and communities. Family caregivers, I suspect there are many in this audience today, are an invaluable resource to our society. They devote enormous time and attention and make so many personal and financial sacrifices for their loved ones. Too often, however, the contributions that these vital caregivers make and the challenges that they face are overlooked in the development of healthcare policy. I remember in my own family the years that my mother, who is now 92, took taking care of my father. Fortunately, I believe it was 8 years that he was at home. Only in the last 6 months of his life did he go into the veterans home in our hometown of Caribou. She was fortunate that my 2 younger brothers and their wives still live in Caribou and were able to help, but it definitely took a toll on her. It was so difficult, and she was determined to be the one who was there for my father throughout all of those years, despite how increasingly difficult it became. I remember one night my father falling on the way to the bathroom. My father was 6'2". He shrunk some as he got older, but he was 6'2". My mother, 5'3.5". And there was just no way that she could pick him up and help him get back into bed. And she called my brothers and was unable to wake them up and had to call the ambulance to help her, and then my brothers came as well. But that's the kind of challenge that caregivers take and face every day. So last year, the Raise Family Caregivers Act that I authored became law. And it stands for Recognize, Assist, Include, Support, and Engage Family Caregivers. This bipartisan law is leading to a coordinated strategic plan to leverage federal resources, promote best practices, and expand services and training for caregivers. I will tell you that in my conversations with caregivers, what I find that they need most is respite care. They need a break from the 24/7 cycle of taking care of their loved one. With the RAISE Act, they are poised to receive access to the resources and training needed to better balance what is a full-time job of caregiving, along with everything else that life brings. And I have also talked to the children of those who have Alzheimer's and who tell me that they've either had to quit their jobs in order to take care of a parent, or they're trying to work, take care of their children, watch over mom or dad, and that is so difficult, and we need to provide more help. As I said, I was so delighted to hear that outstanding presentation on the medical research that is underway, because biomedical research is absolutely essential to making progress against AD. And this vital work, as the doctor pointed out, requires strong federal partners. There simply is no investment that promises greater returns for America than our investment in biomedical research. And in just the last 3 years, Congress has increased funding for the NIH by $9 billion, or 30%. That's huge. And this funding promises to push our understanding of the brain. The National Alzheimer's Project, known as NAPA, which everybody thinks we're talking about wine, but since we just learned there's a connection, that's okay, right? That red wine, and it seems like it was appropriate that we called it NAPA. I co-authored this bill with former Senator Evan Bayh 9 years ago, and it set a very ambitious goal of preventing or effectively treating AD by the year 2025. Now, here's the problem that we had been facing. We did not know how much money we should be putting into Alzheimer's research. So we were essentially plucking, we were talking with the experts, so we were essentially plucking a figure out of the air, an informed figure, because we were consulting with scientists. But this is why this legislation is so important. It created an expert council which actually reviewed all of the literature, talked with all of the experts and with NIH, looked at the number of promising applications for research that could not be funded because there wasn't sufficient funds. And this council was the one that calculated that at least $2 billion per year in research funding was needed to achieve the goal of NAPA. So then I was really strengthened when I made my arguments, because I could refer to this expert council. And that is when it really took off. So last year, along with a bipartisan group of my colleagues, I worked to secure the largest funding increase for Alzheimer's in our history. And it brought us to the $2 billion milestone for the first time, to a total of $2.34 billion. And I am so excited about that. Through advances in our understanding of the brain and improvements in imaging technologies, scientists, physicians, pharmaceutical companies are now able to conduct clinical trials that never would have been funded or possible just a few years ago. And it is leading to new avenues for scientists to pursue. I've made a point of visiting labs all over the United States. It's one of my favorite things to do. And I've and for a while, it seemed everybody was looking at the amyloid plaques and at tau. And I kept thinking, we've got to broaden our inquiries. Now, it is possible that that list of 146 failed clinical trials may be because the medication was tried too late and needed to be tried before so much damage was done to the brain. So it still may be that amyloid plaque could be the answer. But we also know that there are people with amyloid plaque in their brain who never develop AD. So I think we need to expand, pursue earlier onset tests or pursue tests of people with only mild rather than moderate or severe Alzheimer's disease to see if those medications that have been discarded might work if they were applied earlier. But we also need to look more broadly. So from NIH headquarters to the Mayo Clinic, to Harvard, to the University of Pennsylvania, and our very own Jackson Labs, I have reason to be hopeful, having visited all of those places and talked with the experts. For example, researchers at Harvard showed me how a protein called REST, I don't know whether that's what everybody calls it or what they just call it in this particular lab, has the potential for leading to the regeneration of neurons that were damaged in Alzheimer's. And since that question was the last question asked of the physician, I just wanted to bring that up, that there is research going on in that very area. In addition, right here in Maine, the MDI Biological Lab is doing a lot of work on regeneration. Now, they're mainly looking at could they regenerate parts of limbs, for example, and they've looked at how starfish regenerate. It's absolutely fascinating. Right here at Maine Medical Center's Research Institute, which I've also visited, they're looking at growing kidneys from embryonic stem cells. It's absolutely fascinating. And I just share this with you because it's really easy to get discouraged when you read 146 failed clinical trials. I had my father enroll in one in Boston, even though it was expensive trip for them to come down from Caribou to Boston. But you know why he wanted to do this? It was early on. He said, I know it's not going to help me, but maybe it'll help the next generation, which is exactly a wonderful attitude and the right attitude to have. But I want you to know that there is wonderful research going on all across our country, including right here in Maine. And just last month, a study published in Nature found new biomarkers in the blood that can detect Alzheimer's stages before the amyloid starts building up in the brain. This new research is so exciting. So instead of using PET imaging, which they showed me at the Mayo Clinic, to take a look at the brain, we may ultimately be able to identify it through a biomarker that's in the blood. Now, I will tell you, as someone whose family has a strong history, there's a real question about whether you want to take that test before there are effective treatments or means of prevention or a cure. And in addition, as was mentioned, there's a fascinating lifestyle test that have been going on, several that have been going on, that indicates that good habits like the Mediterranean diet and exercise may make a difference in the blood vessel health of your brain. And it's interesting, and it may not be connected, but in some ways I think my own family is a really good model for this, because my mother switched to a largely Mediterranean diet decades ago, and my father's onset of Alzheimer's disease was much later than his two brothers. They both were cognitively very active. They all, I should say both, all three were very active. There was no social isolation that could be a factor. They all three exercised, but the one difference seemed to be the diet. Now, who knows? That's anecdotal, but I was glad that the doctor mentioned that, and it's something that we can look at. Now, after decades of expanding biomedical research, we're also beginning to translate that research into practice. And that requires recognizing AD as a public health crisis. This is a whole approach to Alzheimer's. And the bipartisan BOLD Act that I authored and that was signed into law late last year creates a public health infrastructure to combat AD by promoting education and early diagnosis. Now, we know that public health initiatives save lives, and they've proven over the last century to extend lives as well. Since 1900, public health has added nearly 3 decades to our lifespan. The leading causes of death nowadays are chronic diseases, including Alzheimer's, rather than infectious diseases, which is what they used to be. So the following legislation, the BOLD Act, is building our largest dementia infrastructure for Alzheimer's Act. We always try to come up with cute acronyms, as you can see, with the BOLD Act. And it creates centers of excellence that will serve as regional hubs to promote earlier diagnosis, caregiving intervention, awareness about dementia, cognitive decline, and brain health. And the kind of memory tests that were being described is part of what we're talking about. So this legislation would help state public health departments to take key steps to reduce risk, to give caregivers supports, to gather data, and to encourage early diagnosis, which I am convinced is absolutely essential. Again, and I don't mean to draw so heavily on my own family's experience, but my father was diagnosed early because we knew what to look for. He was on Aricept early, and it may have been that rather than diet that helped him have several good years before the years became far less good. But just as we screen for cancer, diabetes, and other chronic diseases, appropriate Alzheimer's is the first step to improving treatment. That's part of the goal of the BOLD Act, but I also am co-sponsoring a bill that would include in the Medicare exam, the annual wellness exam, a screening for that as well. And I think that would make a real difference. Thank you. So I am very excited about what is going on. We've seen several states and cities like Bangor, where I live, are already establishing public health plans to take on Alzheimer's. Maine is taking action to bring together stakeholders from academia. I know UNE has a great new program. Research institutions, aren't we lucky to have Jackson Labs and MDI Biological Laboratories and the Maine Medical Center, Institute for Medical Research, hospitals, community organizations to address Alzheimer's. From promoting early detection and improving data collection to raising awareness and reducing stigma. That is so important, and that's something we need to talk about as well. And that's where I'm sharing my family's story. I have to tell you that I'm not sure 15 years ago I would have. But nowadays, I feel like it's so important to talk about it and to encourage people to talk about it and to get help. Because if you don't talk about it, you're not going to get the help you need. So that is part of our goal as well. So this collaboration puts Maine on track to lead the nation with a public health approach to the disease. It is estimated that unless we change the trajectory we're on, that nearly half of the baby boomers reaching age 85 will be affected by Alzheimer's. Chances are that they will either be spending what should be their golden years with the disease or caring for someone who has the disease, almost half. And in many ways, it's becoming the defining disease of our generation. So we must not let Alzheimer's define our children's generation as well. Biomedical research, public education, and a public health approach combined with your hard work and the advocacy and work of the foundation will provide the key to charting a brighter future. Thank you so much for being here. Thank you. Thank you.
Thank you, Senator, so much. That's up to you. That's up to you. So, when you heard the previous speaker, Dr. Gramis, and we were delighted that she's here. I mean, Doctor, you really put it in layman's terms, so we would all pass the quiz that you wanted to give out. But when you hear 146 failed trials and Biogen and other pharmaceuticals pulling out, you think your odds are diminishing. But when you hear the senator talk in a bipartisan fashion, because this disease is colorblind,
Exactly.
this disease has nothing to do with politics, but in a bipartisan fashion in Washington, things are getting done. And I'm witnessing Senator's leadership, her commitment, personal stories, and dedication. And what it results for me and everybody else in this room is hope. And we need hope with this disease. We need hope for better treatment, and we need hope for a cure. And Senator, you give us that, and I thank you so much for your leadership.
Thank you.
So, do you want to take the question?
I know you've been sitting for a long time, and we just learned that sitting is the new whatever. Before I've got to go have a luncheon with a group of judges who are going to talk to me about criminal justice.
This is much more fun right here.
Thank you, Senator, for all the work that you do in this area. How can states access funding for the public health, particularly, and also for other foundations that would need to apply for some of the funding?
That's a great question. The law is just now going into effect, but what I anticipate is the Department of Health and Human Services will be providing grant money to state public health departments, but they'll have to apply for it. It'll be a competitive process. But that's the kind of detail, because the law's so new, that we're still working out. And we'll be coming back with announcements on that once those details are coming out. At times in Washington, and this can be frustrating, you write about months later, you say, why is it changing everything? So it'll probably take a bit longer, but that's what we would anticipate. So, yes.
I'm greatly encouraged by what we've heard, but how can we be reassured that the pharmaceutical companies won't rip us off?
Well, I'm so glad you asked that question, but I'll give you another 25-minute speech on it, even though I'd love to give you one. So as the chair of the Aging Committee, I have held 8 hearings to look at the soaring cost of prescription drugs. Now, I understand that it requires a lot of money to bring a drug from the lab bench to the bedside of a patient. And we have patent laws that help to give exclusive rights for a number of years so that that investment can be recouped, because most drugs fail, as we've seen. So you don't want to dampen innovation. But I have to tell you, I am outraged at some of the practices that I have seen. And let me just describe a couple of them. I'll probably get into this and describe more than a couple. But first, let me say that there is nothing that I can think of that we buy that is less transparent, more complex, and more rife with conflicts of interest than prescription drugs. And I want to give you a very specific example of the system. So, pharmaceutical manufacturers want to have their drugs chosen by insurers to be part of the formulary, the list of drugs that, if you belong to this insurance plan, are available to you. The person who is the middleman is called a pharmaceutical benefit manager, a PBM they're referred to. And they are often compensated by getting a percentage of the list price of the drug. Now, just think about that. That means that the pharmaceutical company has an incentive to keep its list price high because it wants the PBM to choose its drug for the insurance company. So there you've got a built-in conflict of interest right there. There's another practice that we've focused on in our committee, and that is sometimes the brand name pharmaceutical company makes it very difficult for a generic company to get sufficient quantities of the drug to do the bioequivalency tests that are required by the FDA before they will approve the generic. Because after all, the generic has to show that it is the equivalent of the brand name drug and equally effective. Well, if they can't get enough of the brand name drug, they can't produce the generic. They can't copy it. And they're supposed to be able to do that after the patent expires. Obviously, the patent expires. Another outrageous practice is called pay for delay. This is when the pharmaceutical company pays the generic company not to bring the drug to market. I don't understand why this isn't illegal under current antitrust laws. That just seems like a violation of antitrust laws. And yet it happens. I'm going to give you some good news at the end of all of this, by the way. The other area that I am outraged about are the increases in the price of insulin. Now, insulin has been around for nearly a century. It was first isolated in Canada, Ontario, in 1921. And the scientists who isolated it and realized the potential for people with diabetes essentially gave away the patent rights. They gave it away for like $1 or $2 because they wanted everybody to have access to it. Well, in the last 5 years or so, the price of insulin has approximately doubled. And before that, it also went up. Now, I realize there's fast-acting insulin and slow-acting insulin, but the fact is it's still insulin. It is not some new drug that was created in a laboratory. And I just think that is outrageous, absolutely outrageous. People with type 1 diabetes have to have insulin to live. This isn't a nice to have, it's a must have. And people, a lot of people with type 2 diabetes need some insulin. Not everybody, but some. And I held a hearing where a young father from New Gloucester testified about his 13-year-old son who has type 1. And he, overnight, found that a 3-month supply for insulin for his son had tripled in price. And he couldn't afford it. He could not afford the out-of-pocket cost, the copay for him. So he goes to Canada to get the insulin he needs to keep his son alive. And I had another hearing where a young woman also with, she's insulin dependent. I think she's insulin dependent. And she needs a continuous glucose monitor to have an even flow of insulin. She has brittle diabetes. She's very difficult to control. She has young children. She's driving them, and she is passed out because of low blood sugar. And this is. And what's more, every time she has like a $2,000 bill. Why not get her continuous glucose monitor and make sure she has access to affordable insulin? The insurance company would save money, not to mention her health and potentially the lives of her children. So you can see you've touched a really sore subject for me, but here's the good news. 3 Senate committees, the Senate Health, Education, Labor, and Pensions Committee, called the Health Committee, which I serve on, the 3 committees have reported bills that are all aimed at reducing the price of prescription drugs. And the bill in the Health Committee has several provisions that I authored, but one would prohibit the brand name manufacturer from playing games with the patent system. And what is happening is when the patent expires, all of a sudden they'll tweak the drug or the packaging or the dosage and file a whole bunch of new patents thicket to prevent the lower price biosimilar or generic from coming to the market. That's not what our patent system was intended, how it was intended to be used. So we've got parts of my bill within that broader bill that I think would make a real difference. And the former there's a category of drugs called biologics that are very difficult to manufacture, and Humira is one, for example, the best-selling drug in the world. AbbVie, the manufacturer, is one of the companies that has filed all these extra patents to try to prevent the biosimilar from coming to the market. And let me say, Humira has been a miracle drug for a lot of people with rheumatoid arthritis, psoriasis, Crohn's disease. So I don't begrudge AbbVie having a period of time to recover what was a huge investment in this truly miraculous drug. But they're making $18 billion a year. I think they've recovered on that one drug. I think they've recovered their investment. And as one analyst said, every month that they can keep the biosimilar off the market, they're earning billions every month. So here's what infuriates me. The biosimilar, which is far cheaper than Humira, is going to be available in Europe very shortly, but it's not going to be available here because of all the new patents. And that's what my bill is intended to prevent. So I hope that's my answer, but I am so worked up on this issue, I can't tell you. So thank you. Thank you. Yes, sir.
Adding to that, is there any consideration in your committees to tweaking the Justice Department or open their eyes to what's going on? Are they getting the system?
The question is there an effort to open the eyes of the Justice Department to be more aggressive on this issue? And there is. That bill's coming out of the Judiciary Committee, on which I don't serve, but we've got both the Finance Committee, the Judiciary Committee, plus our Health Committee working on this issue. But I'll tell you, even more than justice, it's the Federal Trade Commission that needs to be more aggressive in this area. And I've asked them, what do you need? Do you need more resources? Do you need more authority? And it's really more the FTC than the Judicial Department. I've gone way over my time.
Thank you very much. Thank you so much. I know. Thank you, Senator. Thanks again. That's really great. We're going to take a few-minute break. Can you just wait 1 second while the senator leaves? Thank you. And then when we come back, Chaplain Keenitz is going to talk about long-term care. We're delighted to have her here. And also, one thing. Those of you that are still afraid to take a memory screening, we are still available, so please take advantage of that.